Hello. As you can hear, the story for tonight is that I'm still sick, but nevertheless, I'm on schedule. No, I'm not on schedule. Uh, we need to hurry up with our project, finalize it. Hey, Thomas. Hello, Yombo. Hey, Kaspar. Hey, Johnny. Hey, Mr. Triad, Sonic, TMK. Now I need to update the on-screen chat, and then we're good to go, huh? Interact. Here we go. Does it update? Yes, it works. Okay. Sorry. This will be bad because I have a bad cough, like a dry cough all the time. I try to turn around whenever, so it's not going into the microphone directly. Hey, the Shipu. I thought Tuesday czwartek was last time, but it's next week, is it? Yeah. Yeah, it doesn't feel good either. So what? Yeah, but it was a good. It was a good opportunity to have Ponchki anyways. So we had Ponchki on last week, and this week we will have them again. Uh-oh, my GPU is doing weird stuff here. Yeah. Whew. Today will be some debugging stuff going on. Okay, so we have this project here. Wait, let me. I don't have this booster. I have this booster because I need more energy. I don't think the energy is coming from that because it's sugar free. But tasty vitamins. At least it has. I haven't. Oh, Thomas, you missed all the good part. Okay, so $150 for first. This is not working because yeah, we have no external clock source on these MCUs, and they are bugging out. It's hard to program them. And this experiment cost me $150. So yeah, unfortunately. But what we can do is, I have a second board assembled. We can test that. Oh yeah, all right. Off stream, I only was sick and was PCB designing, so I will show you some state. Yeah, but first of all, I want to mention today we will try to put a crystal on that, like a dead bug on top of the MCU. So I hope we can make that work. It will be hard to solder. You see like 0.5 millimeter pin pitch, and I need to hit exactly two, like get two wires in. That will be interesting. So we will work with the microscope today, and then I want to test the speed of the bus. If there are issues. Oh, not teach us yet. And regarding the design, I'm really I really need something else for a chain. Crippled roach. Yeah. Here we go. This is the state. It looks more and more like finished. Um, I have a few design changes. One thing I don't like yet, the worst thing is this VDD that's going in here, because yeah, it's right next to my bus lines. This is only like on the first, no, it could, I could resolve it. First row, I could get the VDD from somewhere up there. Second row, there will be one line less, and maybe enough space here to have like ground around that. But I don't see, like currently I have no space whatsoever. This everything here is full. I can't route it above that MCU. Yes, there are grounds everywhere. We have two ground planes here. So it should be fine. The ground, this is like the distance here is I think 1.6 and 0.16, and the distance to oh, there's also one thing, we can remove the ring from that, so the distance would be actually to the hole, but I think there is some variation. Whoops. Clear filter. So if we remove the ring from the inner layer, a small container, did get to pour it? Yeah, I know. So there is no crosstalk, but I, every single data line here has like ground, is surrounded by grounds. Like even here, I have like kinks like that. I probably the kink in the line is worse than having like this ground next to it interrupted or something. So I'm not sure about that. This is something that we can test today, because I can. Hey Miho, yes, Platin design for the next Ultra cluster, and we're trying to be very like thorough, because each try cost us $150 and we're running out of time. Copper everywhere, yes, we have plenty of copper. So if you, well, wait, here, if you look at that, wait, let me remove, this is our top layer, which is yeah, everywhere ground where it's possible, and I try to connect everything. Oh, one change, the Altium expert is like thermal relief. I don't need them. Yeah, I just removed all the thermal reliefs, which improves things a little bit more. So there's like always some connection somewhere. So ground is balanced on the top layer. Then we have ground. This is a whole ground plane. Then we have signal layer, and now you can see what I mean. There is always like a strip line. There is always copper around that's surrounding the complete trace, except for stuff like this. This was tight, but the ground is like not detached or anything. So there is still like, I mean, here the ground is not going like that, and then it's there. because that's not like a differential pair. It's going somewhere like here, and then it's going through the ground pin, which is somewhere there, and here like that. So here in this area it's not crucial, but I have always like ground vias between each of the data lines here. There are more, like you will see on this layer. Yeah. Oh, what is, yeah, this is, what is this? I might be able to fix that. Can route here because I want some ground around that. Yeah, I can fix that. Let me check that. Yeah, that will be fixed. Whoop. See? VDD MCU. Wait a second. Why is there a VDD MCU 0 still? That should be gone. We have VDD MCU 0 up there somewhere. Wait. Oh! I missed the part. Here. What? No. Oh, this is a complete different story here. Yeah, I can move that down. Wait. Am I right here? I can move that down. Easy. Easy fix. Here we go. Signal fixed. We can move that now. I think this is good. No, it's not enough space. Move it further down, or maybe towards here we have enough space. Yeah, that's good. Yeah. Hey, Ricky Dev. Okay, now we have the ground connected. Okay, maybe I should go like a last check to see if there is like with my strip lines here, if there is a problem, but I don't see one. One thing I couldn't avoid is like here, that one. So that's also VDD, it's not a signal, but obviously the ground will walk around that, so there will be enough like from the thing on the next row. Looks about right here. And then this layer is the same thing. I see this one is I can't move that way further towards this. It breaks like this automatic. Okay, okay. That worked. But this here. It's so tight here. You see that's what I am doing all day long right now. Okay, that looks better. Yeah, the only thing is this one. Okay, I have to live with that right now. I mean, this will be resolved as soon as we reach the second row, and this signal here is a short one. It ends like with the next signal and so forth. 2 weeks or 10 days roundabout from middle of middle of February. So I will place the order this week. For sure, that's what I okay. This looks fine. Okay, don't like that much, but voltage LED, that's all right. It's not no signals here. This one is no good. Beautify is probably some tool for that, but okay, that looks good. Yeah, let's look at it in 3D view. That's hotkey 3. Yeah, this will be the size of the blade, of the final blade, and it's so tight. The board can't be much bigger than that. Probably 1 millimeter, but I need some air around it, so not sure if I would need like to check if it's possible to make it slightly like 0.5 millimeter on each side, because I don't have the space. This is exactly the center, so this will be rotated, and then same thing over there. This is like the copy of one row or something, moved away. I have only like imported four copies, and one is placed. One thing that I think I'm missing the rule for expanding the mask here, because I don't see copper at all. But this is something that I look at that. These are the layers. Oh. Wait a second, is this stack up correct? Yeah, anyways, there is the ground. You look in between. The stack up isn't like perfect. But it's cheap, and I match everything with the impedance and so on. We could go like a little bit more expensive stack up, where the signal and ground planes are closer together, but that's way more expensive. The price almost doubled or something, or 50% more just for the PCBs. Anyways, this is what I did. No. Yeah, that thing, like this thing will be full. This is like the controller. Here will be an edge connector somewhere here, and this will be full of 1024 MCUs. And now we have the crystals here, so that was tight. And this will be placed not by me. This will be manufactured, and that's why ordering, like I need to be sure. That's why I'm doing like the test rows here. They cost me like 150, and I can populate them myself, test things. Manufacturing a set of these PCBs cost like 1.5k. So this is this has to work the first try. There is not much bodging with for 6 layer boards. Damn it. Okay, I'm scared. I'm really scared. Crippled mosquito? What? What do you mean with crippled mosquito? I also added crystal to the main CPU, but oh, we have some designators. I need to remove those. What is a crippled mosquito? Okay, that's that. Now what I need to do is I need to fix get an oh yeah, no, let's do that. Ah. Ricky, the video about this project, it will take probably another 2 months, unfortunately. Oh, I will jump out the window if that doesn't work. And then probably survive because it's not that high. I will lay down there and cry, please help. Okay, let me quickly set up everything. Oh, please, don't jinx it. It will work. I hope. There is no bodging. How do you bodge? At least I hope. I hope it will be. If something is wrong, then I hope it will be only with the row controllers, not with the rows. Because 32 row controllers are manageable, the rows are not. Yeah, I mean, you can always cut traces. That's the issue. The most expensive part are the PCBs, not the parts. So probably it's cheaper to give it a try with assembling. I will check the prices and balance something. Assembling 5 boards might be wise. It will cost only like the parts cost. Middle layer traces. I can show you. We have options. Okay, we have options. Okay, I show you. Switching to microscope. No, it doesn't work. What? Huh? Why not working? Oh, the cable wasn't in right. Now we can see. Okay. Okay, so I can tell you bodging will be easy. So on the new design, the repairability is slightly better because on the new design there will be no traces connected underneath the QFN. So if we enhance, get you in focus. Okay, so new design has no traces underneath that, and okay, yeah, it will be harsh, but I think I have in-pad vias, so I could always cut a trace because on the top. Let me show that. The objective is to test something. Okay, look at that. So obviously don't think the power will be an issue. Then we have the crystal traces. There is the only thing is like the LED that has a connection in pad, but I hope this is not too close to the other one. But we could always like cut it here. So every single of those traces that is attached to this little fella, I could also move that. No, I'm not changing anything anymore. All right. Everything could be is like rooted on the top layer. So we have access in the new design. We have access. In the old one, I shrinked the center pad, which isn't great because that helps also aligning the MCU. So better yield with a big ground pad here. Although sometimes it looks like that here with the vias. I hope that isn't an issue. And this one has some on the bottom, but we can always pull off a leg. I did that before, like pull off a leg or cut it and then put a wire to it. So but obviously I don't want to do 1024 times like a botch on those little things. Maybe this will be painful to watch. Yeah, my light isn't good enough here. Anyways, today we want to put a crystal on there. Yeah. I need the crystal though. Which one is it? Do I have a crystal? Which one is this here? I found a crystal. Whoop. Did I drop it? Yeah, this is not the crystal I was looking for. This is some other crystal. That looks like a 32. Wait a second. Is this like a huge crystal? Yeah, I need to see if this is 32T NSK D32T AG. Is this a 32? Wait, did I use it for? Yeah, I used it for my video thing. Alright, so the crystal is actually bigger than the MCU. Interesting. This is the footprint that I will use, and this is the footprint that I used before. That's a 3220, and this is a 2016. So let's open that. Here we go. We can also hover it in mid-air. What are the ground connections and what is the stuff? god, I need to film this. It's my SD card here. This works. Yeah, that's one I know that, but is 1 and 3 the pads that we need? And okay, let me check if the clock line is detached. I think it might be. Clock line is detached. That's the second here. Oop. So not sure if we should cut it though, because that will obviously give us some trouble. Okay, what do I use? I use some enameled wire. How short can we when can we do it? Maybe I should. I don't have a glue here, so I will. Check if I have it somewhere. Oh, the sheepu, you too. Sorry to hear, mate. Okay, you know what? I have some sticky tape. Let's maybe use that. The sheep will get well. Mate. Here we go. I need really fine tweezers. These are slightly. These are my favorite ones. 14. You know what? I don't put it on top of it. I will put it next to it. We have plenty of space here. Okay. I hope that, yeah, it doesn't jump away. My microscope is a game changer. There's like a 3mm part. Working on that. Like that. gives you way more precision. Yeah, that's what I thought. 1 and 3. Oh, we have some bits! Thank you very much! Oh, that's an M-scope. M-scope, I don't know, it has like a triocular, so it's stereo vision and camera at the same time. It wasn't very expensive, but still not like the super cheapest thing. 500 bucks or something, 600. I think I paid 600 off AliExpress. I bought like a camera with that, but the camera was crap. So I used, let's maybe use ground first, shall we? Where's ground though? This should be ground, I believe. Let's see properly. Yeah, I can see the thermal relief, but I will use do we have a different ground than this? Yeah, but I need like the return path of that needs to be really short. That's I didn't. I mean, we have. Okay, I will stay flat here. No flux yet. It's working without quite well. And I will try to since we have like capacitance matching on the MCU, we can connect it directly to ground at least. That's what I did before. Boop. Oops. Okay. Try with the core flux. To get rid. It's just some connection. It looks like there is a connection. Okay. Oops. Alright, that's the ground. Now we need to get the other sides. for this one. Okay, now I need to find the clock pin here. So, what is the clock pin? So 20 pin 1, pin 2 is clock pin, and pin 3, yeah. Oh, wait a second. Let me check the design. Or the former design on KiCad. Yeah. That's basically these two, 2 and 3. 2 and 3, yeah. All right. Now I need some flux. But not much. A kiss of a flux. Maybe I should do this one first. It will be harder to reach that later. I need to... Oh, can't really... Oh, that's the wrong... I was there. Okay. I don't trust it though. Will probably fall off as soon as I do whatever. Yeah, can't do that with 1024 each blade. I get some. Ah! Some focus on that wire. Trying to dip it like that, and that releases it. Should I go over there? Yeah, that's too far for this one. Unless I bring it closer. Oh, it's gone. Is it painful to watch yet? I think I need to replace the hurt is real. What did I? Oh, something fell down. Okay, let me remove that debugger. Let me replace the low temp soda with the. Oh, that's what I didn't want to happen. Yeah, 0.5 millimeters pin pitch is quite. Soldering pubic hair. It's terrible. Maybe I should have removed the cap first. Ah, that doesn't hold. What? I need more soda in there. Shoot. Give me the other side. Oh, this already, it looks like a really. Is that like gunk? Why is my tip so gunky? Yeah, I can't get off. Okay. I think this one counts. Okay, but now I hope it's not shorting the ground. One down. Now it's even harder to get in there. Okay, I will cut it beforehand. This should be good enough. Oh, it's almost too short. Oh, it's really hard to. Okay. How do I do it? Maybe I get more stable when I attach the other end first. And also I can check. I don't think I can use the other pad. Okay. Okay, this one is attached. Now we will bend it in place. And let's try to convince it with some heat here. This looks so clumsy, but you know how tiny this is? Alright. I think we got this. Yes. Do you see that? These are the wires that we just saw that there. Should we just power it on and see what happens? One more. It will be good. Okay, we can test that. But my continuity tester isn't that great. Somehow suffers. I don't know if it's the leads. Doesn't work. Maybe it's the battery. Yeah. The shunt is done. This thing served me 8 years. Maybe it's time. Yeah, we have to. Hey, do I have another one? I have multiple ones. Maybe. Let me check that. El Chipo. Ah. No. Okay. Continuity is alright. I think we can turn off. Yes. I'm missing a regulator though that I probably want to add if I can find one. I mean, we can use the leaky to power it. Alright, signal clock. Yeah, I need to be sure. Switch the cameras. Whoop. And we could also attach things. 3.3 volts, I think it was here, that one. Let me check that. Reset, ground. 1, 2, 3, 4. Okay, that should be it. TikTok explosion video. Is this a meme? No, not really. Rather, I had like the worst part is over, but still not great. I hope my voice will survive the day. Okay. Oh wait, this is the other linky that we're using. Maybe. This will be ground. Yeah, this is 3.3 volts. I can use this one as well. 3.3 volts. Ground is here, and let's try to okay, the main MCU is still working. The voltage is too low for the blue LED. Mad Scientist project? Yes. Hey, Trippy Cat. It will be the maddest of all the mad projects. The Ultra Cluster. Okay. Why is this? This is. Hello. AJB. Okay. We will try to. Let me get the programmer on screen. And we get the short view here. Okay. No. Status is wrong. I think I got the right pad. Terrible if that doesn't work. Nope. Linky is there. We can clock speed. Let's try a Oh, that's the wrong pad. Let's try again with the right pad. Okay. Failed to set one wire mode. We try. Second ground. Do we have a second ground here? Oh, damn it, Linky, you have only one ground pin. Too short, can't reach it. Something's weird. It failed to set the mode. Okay, let's see if we can get a clock on the crystal. Hey Avra Mitra. Okay. Scope mode. Yes. Yeah, I can. We have always the option to make the jig. Okay. Let me probe if we get anything on the crystal. Oh, there is a clean signal. So I'm not sure. Okay, that's 32 megahertz. Should have a clock. The clock seems to be stable. Let me get on a proper solder connection so we can see if it's, or just a solder block even, see if it's was the issue there. One wire is I don't have a reset there. Reset is optional. Nah, you can always reset over the one wire interface. We did that already before. So that's a thing. Okay. We can always power cycle it if it struggles. Yeah, I need a wire there. Okay. Yeah, the debug interface, I never had issues programming it just with one wire. Or I should use these things here. Where's my wire stripper? Huh? Alright. I have to use the knife instead. What I did on the second version is adding the clock pin, so we have two wired interface, not only one wired if there are issues, you know. In this case we don't have the clock pin. We could add the clock pin, but that's not a botch. Sorry you won't be able to see, but I have no space here for my hand. That's called solder joint. Wait a second. That's the ground pin. Oh no, I used the wrong pin, peeps. That's not like mirrored, the design isn't mirrored, it's damn it. It's probably working fine. Now I just noticed because the ground pad has harder thermals. You can't see anything, I don't care. Let me just quickly add this. Okay. Ah! Alright. We want this one. This one here. Long return path, but still. Ah! Snap. Okay. I'm recording that one. Yes! It's responding. Okay. Oh, what did I do? Wait. I changed the configuration, I think. Nah. Operation successful. Okay. You see that? I need to check the configuration. Oh. Ah! Sorry. Let me mute the microphone. Ah, the dry one is the worst. Anyways, this is worky. Next up is that drained all my energy. I hope I can do until 10. Ah, this is bad. Water, I have some energy drink. it energizes the bacteria or the viruses. Okay, I will power water. Snack is here. Madeleines. I like the with raisins more than the one with chocolate. Just. Oh, a little bit old. Altbacken. Nom, 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 nom. Lemon? More booster. I will sleep really well tonight. I feel much better. Yeah. The classic ones? What do you mean with classic ones? Okay, I'm looking for the 3.3 volts regulators because in that case we will have enough power to supply. Currently we don't have enough. Check. Grab your tea, come back, and we will be good. What is this? LDO 1.3 volts. No good. I need 3.3 volts. What? All right. Have a good meal. I will never ever use all the mini HDMI connectors here. Why? Why do I own all this stuff here? R63? What is R63? Oh, Canon. Yeah, they're back in the game. I heard good things about Canon. Let me check if I have a different one that I can just attach to the pins. Yeah, it's a 3.3 volts regulator. If I can't find the other one, we will Frankenstein this one here. TO package. Let's see if we can find the pinout for that. LP2950L. Da, da, da. Output is there. Okay, one question. Do you think that this view isn't like telling us exactly how to look at it? I mean, it could be like from this side or this side. All right, it looks like the pins are here, so this would be pin number 1. The TO package, this output bottom. Oh, bottom view. Oh, yeah, you're right. Okay, this is output. This is ground. So let me check how I can watch that on. Damn it, ground is here. This will be output. This will be input. I need to be sure that I don't break anything. Okay. I'll put that view here. Maybe clip them a little bit. This is output. Okay, so ground is over here. Huh? Uh-oh. Wait. Okay, so output, input, ground, output. Okay, so I need to put it like that. Let me use, I will clip them shorter. I really don't have some sort of scissors might be better. Oh, where are the pliers? Oh, I found my wire strippers. They're over here. Okay, I can use that. Yeah, something like that. The menu of this soldering iron is terrible. I don't ever know how to leave it or whatever. You need to wait for a moment or. Is it dirty? All right. So painful to watch today. Most probably. Just wanted to keep the option to add the USB later on if I want to test even more. Okay, let's be sure. Center is ground, right is input. Yeah, okay, that should work. Now I need 5 volts, not 3. This is 5, I believe. We can test the voltage, but first of all I need to be sure this is 5. Yeah, let's plug it in. Okay. Ground, and this should be 3.3 volts now. Yes, it is. So this is input 4.7. Okay, there's probably a diode. This is ground and this is 3.3. Okay. Nice. Now we can add the jumpers again. I have planned all the jumpers here. So this is a little MCU. Poop. Oh wait, let me record this again. Alright, let's add the jumpers. This is little MCU. Woo! And this is Biggie. Nothing. Shouldn't that blink? Oh no, wait. This is the Biggie. Wait, huh? MCU2, yes. Here we go. Whoop. Heh. Yoo-hoo! Yoo-hoo! It works! Cringe. Alright. Now we can program both of them. Okay, I don't know what is the issue with the studio. Let me check. To flash download configurations. I changed something. Now it's broken. Clock speed high. Code protect. And that's weird. What's the program address here? MCU flash address is 0, but here it doesn't like it. Now it's stuck or what? Damn it. Flash origin 0. Can I reset that somehow? The stupid thing is erase. Yeah, erasing is done with power. Where is this stored? The configuration. Starting fail to program or verify. Yeah, because it tries to upload it to the wrong thing. Okay, let me close that. That is the other one. That is the other MCU. MCU type. Erase all, program verify, reset, run. Okay. Let me check if I can find the settings. It's so weird. Uh, 570. Okay, code. Example. Okay, before settings. Need to make sure there is nothing doxing me in the come on. Okay. Core. No. No. Now it works. What? Ah. Okay. Never change the address. This is so weird. That was it. Look at that. It has to be 0, otherwise it doesn't work. And if you touch it, the only way to change it back is going into the template and changing it there. That's weird, but this is very specific for this MCU. The other ones start at, the flash starts at 8 whatever address, and this one at 0. Alright, now we can do SPI stuff, huh? Should we try? I would say we have some test pads here. I want to see let's go for it. Okay, let's look for the example. Okay. I to S, I to C, S, STDIO, SPI. One line, half duplex, 2 lines, SPI, DMA, SPI, LCD. Wait. This isn't available at I think this is not LCD. That would be parallel, or is it? No, that's not parallel mode. I think this okay, obviously we want SPI DMA. You have to wait a few weeks. We don't even have a board for that. That little thing. This little tiny little thingy. That will be grand. Okay, let's see. Full duplex configuration, SPI mode, host mode. DMA get flag status. Okay, we need to use that printf. That doesn't. We don't do that. Host modes. Bomb. Enemies down. DMA channel. While host mode. Okay. Printf rx data. Yeah, are we sending anything? It's only where is the size coming from? What is it doing? That's probably the define. Here, size 18 bytes. Send something. Yeah, size. Let's receive data. Host mode. What is TC? Okay, how does the slave mode look like? SPI flag TXE. That doesn't look like. Oh, that's DMA receiving or what? Where's the DMA sending? Send data. Yeah, that's sending individual bytes. It's weird. It doesn't look like this example is fully implemented, huh? Like the full feature set. Okay. SPI full duplex. Let's go send data, DMA comments. Transmit CRC, calculate, okay. Oh. Okay, let's start with that first. Is this U16? Save? Why not? Oh, sorry. Excuse me for. Let's do 8 bits. We need to find out what I did there. Which SPI is it? That's PB345. That's not this one. This is, yeah, 3 PB345. PB345. Here we go. So we have SPI. Clock. SPI3 Miso Mosi. So SPI3 it is that we want. Let's leave full duplex in it. Let's leave that. Oh wait, this is transmitting all the time, is it? Yeah, I think this is looping or something. Yeah, that would work. We can also do DMA transmit full duplex. Yeah, let's just do our own SPI initialization. We clone that. cough isn't great. I can taste blood. Gross. Loony in it, okay. Let's do loony in it here. GPIOB SPI3 oh okay. Pitfall. Okay, here we go. Host mode. Pin. Three, 4, 5. 3, 4, 5, and it's not alternate function, is it? Yeah, it is alternate function. SPI 3 SCK 3, 4, 5. Okay. 50 megahertz floating. This is mode. Meso master in, slave out. I'm sorry, this is bad for any people with headphones. Clock and master out. Yeah, this is correct. Floating 50-50. Okay, we don't need that crap. Direction. SPI direction is just one line TX. SPI mode for now. Host master. Then we have data size 16 bits. Let's do 8. Structure, yeah. Soft is we got control of that. What other options do we have? Hard. Baud rate, prescaler, LSB. CRC polynomial. Do we do can we turn off CRC? We could, huh? Oh, that's the DMA. And that should be 3. Okay. Ja. Ja. No, ja. Five volts. Let me switch that. We have another 5-volt pin there. Okay, let's see if we can get a signal there. Ground, yeah, we have no ground that's close here. Just that spring. Okay, I don't think we need the spring yet. Just use the pins here, so it will be a long ground. Alright. Let's see if we get anything out on the SPI. Nah, this is noise. This probably, wait, the center is the clock? What is this? No, this is not something, because, wait, it might be something. Master in, no, Mosey. This one. There's nothing. Oh. Oh, it was the clock. Clock, Clock is not high enough. This is like, we need faster. Signal integrity. Amazing. Frequency so far. Trigger. Where's my trigger? Alright. 62 kilohertz is working. Okay, 62 kilohertz working. Let's try increase the speed. Prescaler. Where is it? $64. Prescaler is, let's see, 2. But this is running at 8 megahertz, I believe. So, wait. Here we go. Nope. Oh, okay. 2 megahertz. Alright, alright. Now I need to fix the clock because this is still I think configured with external crystal. We don't have external crystal. Yeah. Let's see if we can internal. It is data. I just gave it a byte with 010101. Okay. This is not working. Prescaler. Oh wait, huh? Yeah, it didn't boot. without the crystal. Okay, so I had issues with booting. Maybe the voltage is too low. Let me try that. 120. Yes. Ooh! 16 megahertz! Sweet! That looks the integrity. Pips. Ah! Not shorting here or anything. This is impedance routing. This is impedance routing, my friends. Impedance matched for 50 ohms. 60 megahertz. Okay. Okay. Let's try. We can go faster. Prescaler. I think we can do maybe even faster. Nope. Let me try. Last one. Nope. It doesn't do faster than 16 megahertz. Gigahertz. Gigahertz. Oh, wait. Isn't that 32? Because I have 0, 1, 0, 1. It sends like 1. That's 32 megahertz. Because a full cycle are 2 bits. Oops. Let me check. This is the clock. Oh! Clock line! 32 megahertz! Yes! Okay, peeps. This is... And the other one is even better. Oh, this is amazing. This will be grand. I need to take a picture. This is amazing. Wait a second. Need to take a picture with my phone. Okay. This is crazy. Okay. That's it. We're done. 32 megabits. Can we do there is 2-edge mode. There is 2-edge mode. Oh, this is the final version. DDR, yeah, more or less, yeah, I think. Let's try, but that doesn't work, I think, at the highest prescaler. If we have prescaler 2, then this mode didn't work before. Okay, let me check. Program it. Nah, this is the highest we can go. 2H doesn't work anymore. Alright. Gigahertz. Alright, I'm happy with, I was worried the signal integrity wouldn't be great. Okay, the thing is, we don't know yet, it's floating. Like, what happens if we have more consumers? This is just like with dangling ends. So currently only one MCU is populated. This was the design. So we have like some antennas and only one MCU, but I guess it is alright. What's 50 kilo ohm? What is the 5 mega ohms if of a pin? The resistance should be quite high. So, all right. Yeah. I'm happy. I'm happy with the result. What do you think? Should we end the stream at a good note now? I'm sorry. I have to maybe keep it short today. Oh, my voice is going away as well. Yeah. I hope next and while it works, yeah. All right, peeps. You want magic smoke? You had magic smoke today from a second. Check that picture. Okay, wait. Pink. We can set up pink. Oh, I should be careful not shorting the little MCU. I just shorted it. Yeah. Ah, what did I do? Phew. Look at this. It's suffering. I don't know what's happening. Let me turn off. Oh! Oh, the LDO is quite hot. I don't know why. Shouldn't be that hot. I shorted it. Something's shorted here. Yeah, this is smoking hot. Yeah, this is a magic smoke for you. It's overheating. But why though? Shouldn't consume that much power. Is there like a short somewhere on the board? Let me touch it. Nah, I don't feel any warmth except for the LDO. Okay, that was number 4, I believe. Yeah, now it's working again. That LDO isn't the best. Ah. All right, peeps, what do we do? I think this is a success. The signal integrity is amazing. Get clean edge at 32 megahertz. Should we take a look at the calculations? Me. Okay. Oh, read in Mr. Bean voice magic. I don't know how he reads that. Sorry, Thomas. Magic. Maybe like that. Okay. Level 0. 500 kilobits. Yeah, we have no way of. This is too much. Like if you calculate, if we would transmit, we can downstream. Theoretically, we could maybe downstream 32. Sorry. It showed up. I just was distracted. 32 million bits times 65536. These many bits divided by 8. Bandwidth is 260 gigabytes a second. Gigabytes for graphics card with 262 gigabytes. That's a lot of data, huh? There is no interface at the other end that could receive that. I have like impossible task. Yeah, I have a gigabit Ethernet here, so I would need to set up 260 gigabit Ethernets to digest the data. And I don't think the FPGAs will be able to process that either. Congest the data. It will be at some level. It will get just stuck. But the good thing is, the more bandwidth we have, the more time we have to process it. Yeah, it's gigabyte. Oh yeah, you're right. Oh, what? Okay, so times 8. We need like 2000 gigabit networks. Crazy. And if we do 32 megabits times, oh, it's already like per blade we have already 32 gigabit per second, because we have 32 megabits times 1024. I have no clue what we need, like to take a good connector that is capable of transmitting these datas. All right, peeps. I had enough for today. My voice is already gone. I'm so sorry. The streams appear short, but this is the best I can do currently. It's already the third week that I'm sick. It's the starting week. No, wait. Last week was the first time. Yeah, no. All right. You heard my cough. It was bad. I hope whatever is still in there will get out. Yeah. I also I mean the communication in between within the blade might be, I don't know. I don't know how to process that data. SPI isn't the bottleneck anymore. That's perfect. We don't even need like the parallel bus then. We can transmit everything with the single wire SPI. Alright, peeps. I see you next time. Bye bye, everyone. That was a success. Look at that. We put that crystal on there upside down. Worked. We botched this LDO here and shorted it, but nah, it's not hot anymore. So I shorted it somehow. We shorted the LDO, still worky. Fixed IDE bug by changing the settings. Made SPI work fast as possible here. And yeah, I see you next time. Bye bye.